Now the next problem is, that is, prove 1 square plus 2 square plus 3 square plus so on up to n square is greater than n cube over 3 for all n belongs to natural number. Here in this problem we have inequality. We have to prove this inequality by using principle of mathematical induction. So we will do it by principle of mathematical induction. We state that there is a first step is that we have to suppose statement as P of n. So we are going to suppose let P of n is 1 square plus 2 square up to n square greater than n cube over 3. So we have to prove this statement by principle of mathematical induction got to be true. So the first step is, that is step 1. We prove it for n is equal to 1. So for n is equal to 1, what is the result of Pn? By substituting n is equal to 1 in right hand side and left hand side. So left hand side gives, substitute n is equal to 1 in n square. It becomes 1 square is equal to 1. And in right hand side we get n cube over 3, that means 1 cube over 3. 1 cube means 1, that is 1 over 3. So we can see that 1 is greater than 1 by 3. It is true. Therefore, P of 1 is true. So the result is true for n is equal to 1. The first step is fulfilled. Now the step 2. In step 2, we assume that result is true for n is equal to k, that is P of k 1 square 2 square up to k square is greater than k cube over 3, that is P of k is true, that is statement is true for n is equal to k. Now the step 3 involves result of step 2. Now we have to prove the result for n is equal to k plus 1, that is P of k plus 1 implies 1 square plus 2 square up to k square plus last element is k plus 1 whole square is greater than, replacing n by k plus 1 whole cube over 3. So we have to create this result. For this we will take left hand side. So taking left hand side, that is 1 square plus 2 square plus 3 square so on k square plus k plus 1 whole square. We will use the step 2 result in this, that is 1 square plus 2 square up to k square. We have it is greater than k cube over 3. So we will use this result in step 3 by replacing this quantity by greater than k cube by 3. That is, we have 1 square plus 2 square plus 3 square k square plus k plus 1 whole square. We are going to replace this quantity by greater than k cube plus k plus 1 whole square using step 2. Now we are going to solve this step, so we will take the sign equal because we are going to solve this step. This step is equal to this. K cube plus 3 times k plus 1 whole square over 3 by taking LCM. So open this square bracket. It gives a square plus b square plus 2ab. And open it. That is k cube 3k square plus 1 plus 3 plus 6k over 3. What is our requirement? Our requirement is this whole quantity should be greater than k plus 1 whole cube. So if we see that k plus 1 whole cube is equal to, that is a trick to acquire result. It gives a cube plus b cube plus 3a square b plus 3ab square, that is 1 square. So if we have k cube plus 1, 3k square plus 3k, we will replace it by k plus 1 whole cube. So here we can see that we have a cube, we have 1, we have 3k square, we have 3k, and the remaining terms are 2 plus 3k. 2 is from this and 3k is from this. This is the remaining term. We can see that it is turned up into k plus 1 whole cube over 3 plus 2 plus 3k over 3. So we can see that this plus some quantity, it is always greater than k plus 1 whole cube over 3. But there is a question, what about this quantity? Is it positive always? Yes, as k belongs to natural number and a natural number are positive number. Therefore 2 plus 3k over 3 is always greater than 0. Because of this reason, this whole quantity is greater than k plus 1 whole cube over 3. That is, we can see that pk plus 1 is true. Therefore, by principle of mathematical induction, Pn is true for all n belongs to n. So in case of inequality, we have to solve question very patiently and very quickly. Now the next problem is that contains also inequality is, this is for practice. Prove 1 plus x raised to power n is greater than or equal to 1 plus nx for all n belongs to n. Same, first of all we will give the name this statement as Pn. P of n is 1 plus x, that is let, because we are supposing here 1 plus x raised to power n is greater than or equal to 1 plus nx. So the first step is, that is step 1. For n is equal to 1, what about P of 1? Taking left hand side, it states 1 plus x raised to power 1, that is 1 plus x. And now right hand side, 1 plus 1 into x is equal to 1 plus x. So these two terms are equal. That is, we can say that 1 plus x greater than or equal to, because equality hold here. Therefore, P of 1 is true. Here it is clear that we have to prove either it is greater than or it is equal to. Then our result will be hold. Now the step 2. Step 2, we have to assume that result is true for n is equal to k. That is P of k. That is 1 plus x raised to power k is greater than or equal to 1 plus kx. That is P of k is true. Now, as we know that by principle of mathematical induction, if pk is true, that implies pk plus 1. That involves third step. Now the step 3 is, that is the third step, we have to prove the result for n is equal to k plus 1, that is p of k plus 1, that is 1 plus x raised to power k plus 1 is greater than equal to 1 plus k plus 1, replacing n by k plus 1 in the inequality. That is, we have to prove this result. So this we have taken left hand side. That involves 1 plus x raised to power k plus 1. This can be further factorized as 1 plus x raised to power k into 1 plus x raised to power 1, because x raised to power a into x raised to power b is equal to x raised to power a plus b. If base are same, then these powers are added, and powers are added, then it can be factorized into these two factors. So we get 1 plus x raised to power k product 1 plus x. As we know that in step 2 we have 1 plus x raised to power k is greater than equal to 1 plus kx. So we will use step 2 in step 3. That is, we will replace this by 1 plus kx, that is in step 2, that is greater than. Therefore, by using step 2 in step 3, we get this is greater than 1 plus kx into 1 plus x. So we multiply these two terms. So we will write here equal to, not greater than, because this step is not greater than this step. This step is equal to, because we are solving this step. You have to understand this. So it becomes 1 plus kx square plus kx, that is 1 plus kx square, that is x, that is kx. So we get these steps, and 1 plus kx square, from this we will get k plus 1x. If you see that we are near about our result, that is 1 plus k plus 1x in one bracket plus extra term. Now what can we say that, as k belongs to natural number and xk is positive, then kx square is greater than equal to 0. If this term is equal to 0, then this will be equal to right hand side, and if this sum is greater than 0, then this is greater than this quantity. So we can say that this is greater than equal to 1 plus k plus 1 x. That is, p of k plus 1 is true. So solving inequalities, we have to mind it that what should be our result and how can we get this result by some trick. So by principle of mathematical induction, Pn is true for all n belongs to n.